Yeah, welcome back to session number 3 of acids, bases and salts. Today we are going to discuss about the properties of bases. As we know that we have discussed the properties of acids in the previous session. There are 8 properties of acids. Like that, here we are having there are 7 properties of bases which we are going to discuss today. Then we'll discuss about pH value. Okay. So look at the first property of base. So before going to see the properties of bases, do you know what are bases and how to identify the strong base and weak base? And what we call if the bases gets dissolved in water or soluble in water. The bases which are dissoluble in water, we call them as alkali bases. Am I right? And then there are strong bases and as well as weak bases. Now you see here the base which is soluble in water is also called an alkali base. Examples: sodium hydroxide NaOH. And then here just identify the color of the bases here. What is the color of NaOH? White. Then calcium hydroxide CaOH taken twice, white in color. Almost all the bases are in white in color. Potassium hydroxide KOH, white. Ammonium hydroxide NH4OH. This is the weak base among all the bases. Magnesium hydroxide MgOH taken twice is also known as milk of magnesia. Okay, so these are the bases we have seen here, and then chemical bases basically, and then we'll move to the identification of strong base and weak base. Okay, now classification of acids and bases depending on the number of H plus and OH minus ions. So if number of H plus ions are more, then we call them as strong acids. The number of H plus ions are less, we call weak acid. If number of OH minus ions are more, we call strong base. If the number of OH minus ions are less, then we call that solution is weak base. Strong bases. The base which give more number of hydroxide ions in aqueous solution are called strong bases. Example: NaOH, KOH, NH3, etc. Is it right? NaOH gives rise, if you dissolve in water, it gets soluble and gets separate Na plus and OH minus. Is it right? And weak bases. The bases which gives less number of hydroxide ions in aqueous solution are called weak bases. Example: NH4OH, ammonium hydroxide. Okay, and if you dissolve this in water, NH4OH gets soluble and gives rise NH4 plus OH minus in aqueous solution. Is it right? So here you can see that OH minus is there and OH minus is there. The solution which gives OH minus ions are known as bases as well. We can say that. At the same time, NH4 plus and OH minus, this is weak base, and these are the strong bases. We know very well in acids as well. Strong acids HCl, H2SO4, is it right? HNO3, and in weak acids CH3COOH, CH3COOH, and strong bases NaOH, and then KOH, NH3 also we have discussed just before, and then weak base NH4OH. Is it right? So remember, among the following, which of the following is strong acid or strong base, or weak acid or weak base? There's a chance to ask the question based on this. Is it right? So let me move to the next slide so that we can discuss the properties of base. Properties of bases. The first property, bases have bitter taste. You can see the facial expressions. And then second property, bases feels soapy to touch. Okay, bases feel soapy to touch. Third property, base turns red litmus to blue litmus. Basis turns red litmus to blue litmus. Okay, whereas blue litmus remains blue only. Red turns to blue. So here is the question or the trick to remember bar. Okay, trick to remember bar, BAR. Okay, blue litmus turns to red litmus. Okay, blue litmus turns to red litmus, that is acid. Okay, and red remains red. So it means final color is red. It means acid solution. Okay, whereas if red turns to blue, RBB, red turns to blue, and blue remains blue, triple B. Okay, so these are the bases. If red turns to blue is base and blue turns to red is acid, bar. Okay, keep it in mind. So here this solution is base solution. So far, how many properties we have discussed of bases? Three properties. Let me recall. First one is bitter to taste. Second one is soapy to touch. Third one is red litmus turns to blue litmus. And the fourth one, base conduct in solution electricity. Like acids, bases also conduct electricity. So how many properties are over? Four properties. Bases also conduct electricity and they act as electrolytes. Bases react with some metals to form hydrogen gas. Here, if you see sodium metal, potassium, calcium, magnesium. So here, if you see, there is no chance to react with these because they all comes under bases. Their hydroxides comes under bases. So here, NaOH, if reacts with Na, there is no chance to get hydrogen gas. Okay, that's why bases always reacts with only two types of metals to liberate hydrogen gas. One is aluminum and another is zinc. Keep it in mind. So here you can see that NaOH reacts with Zn. Okay, gives rise Na2ZNO, ZnO2. Okay, sodium zincate plus H2. Okay, so this is a reaction when base reacts with metal. So keep it in mind. Either acid or bases reacts with metal, which gas gets liberates hydrogen gas. Exactly. But not all metals with bases. Only two metals are there here: aluminum and zinc. Okay. NaOH aqueous solution, that is sodium hydroxide base, and zinc, which is solid in state. Zinc, a metal, gives rise in the presence of heat. There is no chance to react directly because sodium is more reactive than zinc. So to displace ions here, okay, to separate the ions, we need to heat. We need to apply the heat energy to this so that sodium zincate gets formed Na2ZnO2 aqueous sodium zincate salt and H2 gas. hydrogen gas. Is it clear? So this is a fifth property of base. Now let me see the sixth property. Before going to sixth property, let me recall first five properties. What are those first five properties? First property, bitter to taste. Is it right? Second property, soapy to touch. Third property, red litmus turns to blue, that is base. Fourth property, conduct electricity. They conduct electricity. That's why we call them as electrolyte. Okay. And fifth property, they reacts with metal. Metal plus base. What will get? Gives rise salt plus H2 gas. S means salt. With salt, metallic salt. Is it right? Now we'll discuss sixth property here. Bases reacts with acids to form salt and water. As we have noticed that when acid reacts with base, gives rise salt and water. The same equation you can write here as well, because either acid reacts with base or base reacts with acids. Both are same. Is it right? So here NaOH is base, sodium hydroxide, which is base here, reacts with H2SO4 sulfuric acid, gives rise Na2SO4 sodium sulfate salt plus H2O water. Is it clear? So when acid reacts with the base, gives rise salt plus water. And seventh property you can see here, bases reacts with non-metal oxides to form salt and water. Hence, non-metallic oxides are acidic in nature. We have seen when acid reacts with the metal oxides instead of non-metal oxide, then the metal oxides are basic in nature. But whereas if you see here, non-metal oxides are acidic in nature. Non-metal oxides. So always remember, acids reacts with metal oxides, whereas bases reacts with non-metal oxides, non-metal oxides to give salt and water. So if you see here, acids reacts with to get salt and water, what we need? Base. So that's why metal oxides act as basic in nature. Here again, if you see, base is there to react with acids, then only we'll get salt and water. That's why non-metallic oxides acts as acidic in nature. So base plus acidic in nature here. Acidic in nature. Finally, what we'll get when acid reacts with metal oxides? We'll get metallic salt. Base reacts with metal oxide, non-metal oxides also will get salt here. Is it right? But the reaction of metal oxides are basic in nature. That is what we call nature of the oxides here. Non-metallic oxides are acidic. Metallic oxides are basic. Keep it in mind. So acids always react with metal oxides. Base always reacts with non-metal oxides. Okay. See the example here. Calcium hydroxide. Okay. CaOH taken twice, which is base here, reacting with carbon dioxide CO2, which is non-metal oxide, gives rise calcium carbonate CaCO3, which is solid in state, a salt plus hydro water. Here it is H2O. Okay, salt plus water. Is it right? So this is also a type of reaction where non-metal oxides react behaves like as a acidic in nature. Is it clear? So here we have discussed 7 out of 7 properties of bases. What is the first property? Properties of bases. First property says so bases are bitter to taste. Second property, bases are soapy to touch. Third property, bases cut changes red litmus to blue litmus. Fourth property, bases conduct electricity. And fifth property, bases reacts with metal to gives hydrogen gas only with aluminum and zinc. Sixth property, base reacts with acid to gives salt and water. Seventh property, bases reacts with non-metal oxides which are acidic in nature to gives salt and water. Now we'll move to the next concept, that is pH scale. Okay, introduction of pH scale. So here, before moving to the pH scale, let me see, let me tell you what is the pH scale. P means potenge. P means potenge. P stands for potenge. Potenge means strength. Potenge is the word in German. The meaning of the word potenge is strength of what? Hydrogen. Strength of H plus ions. Okay. If you see here, to take a scale of range 0 to 14. The range of pH scale is 0 to 14 and exactly middle value is 7. Is it right? So from 0 to 7, this is acidic in nature, acid, and from 7 to 14, that is base, which is not equal to 7 but which is not less than 7. Exactly greater than 7 is base and less than 7 is acid. But exactly 7 is neutral, neither acidic nor basic, neutral. Okay, neutral solution. Now, if you see here, from 0 to around 2, it is strong base, strong acid, which is closer to 7 but less than 7, 5 and 6, weak acid. And here from 8 to 9, above 7, up to 9, weak base, and 12, 13, 14 comes under strong base, and remaining portion is just base and just acid. Okay, keep it in mind, and we'll see the solution with color and then its pH value. Okay, we'll move to the concept of pH scale. Keep it in mind. What is P for? P is nothing but potenge. Potenge in the sense strength of H plus ions. Strength of acids and bases. So acidic nature increasing this side because H plus ions are more, and here basic nature is increasing because OH minus ions are more and H plus ions are less. So in case of H plus ions concentration, so this is acidic nature. This is decreasing of H plus ions concentration, decreasing H plus, increasing H plus concentration. So variation of pH with the change in concentration of H plus and OH minus ions. The strength of acids and bases is measured by a pH scale. In pH, P stands for potential and it means strength in German. Okay, so you can see the color of the solution or paper. When the pH is 0 is strong acid, that is red, orange, yellowish color, and light green and dark green, sky blue and then dark blue and then violet color or purple color. Is it right? Dark blue color. So here you can see that, take a solution, unknown solution, then this is what we call a gastric juice. The juice, if you take and then to identify its pH value, take universal paper which is yellow in color. Okay, universal litmus paper, immerse in the solution, then identify the color of the paper after taking out. Okay, take it out and then notice the color of the paper. That is, you can see here, it is between 0 and 1, the color of the paper. So its gastric juice pH value is 1. It is not an exact value, it is an approximate value. Now next juice is, can say that lemon directly, lemon juice. Immerse the universal paper and then notice the change in color of the paper. Is there any change? Almost the color is equal to universal indicator. So it is in between 2 and 3. So the pH value of lemon juice is around 2. So it is not an exact value, it is an approximate value. 2 to 3, in between 2 and 3, the pH value of lemon juice. Take another solution, that is pure water. Immerse the universal paper into this. And then notice change in color. Notice the change in color of the paper. So that is a green color. So it is between 6 and 7 and 8 for pure water. So it is, will count it as neutral. So that is the pH value of this pure water is 7. Okay. Take the next solution, that is milk of magnesia. That is nothing but MgOH taken twice. Is it right? Magnesium hydroxide, milk of magnesia. Okay. Now immerse the universal paper in this solution. We know that milk of magnesia, magnesium hydroxide, is acidic or basic. So this is a base solution. We'll see the value which is nearby 10 and 11. Notice the color, change in color of the paper. So here it is blue in color. Is it right? Is it dark blue or sky blue or light blue? You can see here that it is in the form of the light blue here. So milk of magnesia pH value is nearby 7. And the last, sodium hydroxide. So actually sodium hydroxide is a strong base. So we can guess its pH value directly, NaOH. So if you immerse the universal paper in this, so it turns to dark blue or violet color. Is it right? So here, or purple color also we can call here. So it is in between 13 and 14. So its pH value is 14. So universal indicator with different pH values we have seen. And this is yellow color is universal indicator. Okay, universal indicator. With the help of universal indicator, we have identified the pH value of these following juice. Okay, the gastric juice pH value is 1, and then lemon juice pH value is 2, and pure water pH value is 7, milk of magnesia pure pH value is 10, sodium hydroxide pH value is 14. Is it clear? So in this is the way to identify the pH value of the following juice. You can do this activity in the lab as well. Okay, so in the next session we'll discuss about the importance of pH value in our daily life. Okay, so far we have discussed what is the range of the pH value, 0 to 14. So what do we call if the pH is 0? Strong acid. What do we call if the pH is 7? Neutral solution. What do we call if the pH is 14? Strong base. What do we call if the pH is 5 or 6? Weak acid. What do we call if the pH is 8 or 9? Weak base. Is it right? Strong acid, strong base. Weak acid, weak base. Keep it in mind. Nearby 7. If the less than 7, that is acid but weak acid. Nearby 7. So these two are weak acids and these two are weak base. And here two are bases and strong base acids, strong acids, strong acids. Keep it in mind. Okay, so in the next session we'll discuss about the importance of pH scale or pH value in our daily life. Okay, before that, let me finish this task. So the few solutions are there, and the color of the pH paper and approximate value of pH, and then nature of substances. So first, saliva before meal. The pH paper is green. Its value is more than 7. Saliva before meal, it means base. Saliva after meal, so it's yellow in color. pH value is 5.8. Acidic in nature, below less than 7 it is. And lemon juice, we know very well, lemon juice is acidic in nature. Its pH value is approximately 2.5. Okay, and then colorless aerated drink. So some drinks which you can see that acidic in nature, which is pH value is less than 7. And then carrot juice, pH, it is also acidic in nature. Coffee, yellow, pH value is 5, acidic in nature, but it is bitter to taste. Tomato juice, 4.1, acidic in nature. Tap water, green, 6.9. Okay, tap water is it is shows exactly clear nearby 7, but pH value is less than 7. That's why we consider it as acidic in nature, but it is neutral almost. Pure water is neutral. Okay, 1 mole of NaOH, blue, base pH value is 13, basic in nature. And 1 mole of HCl or red, strong acid, pH value is 1, acidic in nature. Is it clear? And we will continue in the next session with importance of pH in everyday life. Is it clear? So see you in the next session. Take care, all of you.